Lesson 6.2b Binomial Probabilities using your calculator today is what we're going over. This is basically instructions on how to do what we were doing the other day in class regarding the binomial probabilities, but with your calculator. Specifically, these will work with the TI-84 and 83. And so what we're going to do is, again, a reminder that binomial probability distribution formula, right, the mouthful, equals BPDF. Your calculator uses the abbreviation right here, binom PDF, right? That's where it comes from right here. And where we do to get there is we're going through our distr second vars button. So it's a second plus the vars button. So no clue where that is. So here it is. Here's your calculator buttons. You hit second, and then vars is right next to the clear button. And DISTR stands for distribution. So these are like normal distribution, etc. We're not in those yet, so we're going to click down until we hit to the, it goes all the way to 0, then it goes to A and B. Right? Both of these are the binomial PDF buttons. Okay. So which is which? Why is there two of them? The A is for when we're doing the probability of our successes equals a number. So when it's equal to a number. And then once we hit that button, so again, we'll go back there, we'll hit that button. Okay. It tells us trials, what's our p-value, what's our x-value. Right? It gives us that information right there that we can put in. On an 83, it will prompt you, it'll open up and say binom PDF parentheses, kind of like sine, cosine, right? It'll open up parentheses, and you need to put in what is n, so the number of n, comma, put in the number for p, right? It's the success rate, the probability of being successful in a decimal form, comma, and then r is what you're looking for in terms of how many successes out of how many trials, okay? And then parentheses, and then you're ready to go. Okay, so a little different on the 83. Okay, binomial CDF, the B button, the difference between the two would be if you're looking for probability of successes of less than or equal to a number, right? So I would specifically less than or equal to. This allows us to compute if we want to find all successes for values 3 or less. Okay, this can also be useful if you are trying to calculate for the probability of, say, R is more than 3. Right? This is another way to say this would be R greater than 3. Okay, so for finding the probability that R is greater than 3, we're going to do 1 minus the probability that R is less than or equal to 3 so that we can use the binomial CDF button, right, which was the B of the two. Next page, we're doing page 236, number 9's question, which is Manitoba northern pike are hardy, tough fish. It was found that they have a 5% mortality rate. That being only 5% of the pike that were caught and released died. Okay, suppose a group of anglers caught and released 16 pike in one day. Calculate the probability. Okay, so 5% is their success rate, right? Because actually, sorry, that's a Q. Q is 5%. 5% would be dying, so dying would not be considered a success. So that means P is going to be 95% chance that they're going to live. Okay? So again, just make that a note. We could put that success would be dying. Sounds a little grim, but then you'd have to keep that in mind when we're talking about all the fish living down here for number C, letter C. N is the total number of trials, and we have 16 trials because that's how many fish we caught. Okay, so we're finding the probability that none of the fish die. So again, we're looking at what's the probability that none of the fish dies would be that all of them survive. This would be probability of R equals 16. 16 fish live. Okay, and so using our calculator, we've got 16 trials. Okay, success rate. It's 0.95. And then lastly, the R value, I think is what it's asking for here. It says X value, but we want how many successes? We said here 16. So click 16. Oh, there it went. 16. paste, puts it in for us. Okay, hit enter, and we got 0.44. So it did all the work for us, 0.440. So basically a 44% chance that all the fish will stay alive. So out of 16. So doing probability that fewer than 3 fish died. So again, this is 16 minus 3 because we said dying would be kind of a failure. So we're going to say this is a probability that 13 or more fish live. So R is greater than or equal to 13. Okay, so remember yesterday, to find this, we had to do probability of 13, that R equals 13, R equals 14, R equals 15, R equals 16, and add them together. That's a lot, right? Our calculator can do it for us. How can we rewrite this so that we're using the less than or equal to, right? So we're going to do 1 minus the probability that R is less than or equal to 12. Okay, and so we can do that in our calculator. We can do this P probability of R is less than or equal to 12 in a calculator. This just means that we are going to have to use the other form. So again, we're hitting second distribution button, so bars go all the way down. This time we're going to do the B button because this means the less than or equal to. Okay, trials is still 16. Probability of success is a 95%, and your X value this time, and again, this is the value, is right here, 12. So we're putting in 12. Go down, paste, puts it in for us, enter. And we have a 100% chance. That doesn't look right. Oh, I see I have a typo. We're going to do it one more time here. 16, not 0. So we'll go back down to B. And again, it's 16, not 1. That should make a lot more sense now. That's why chance was 1. Now that looks better. Okay. Now chance that 12. This is all the chance that 12 or 11 or 10 or 9 or 8 or 7 or 6 or 5, all the way down to 0 of your fish live, right? Because we're talking about living being a success. Okay. So this is 0.07. So that's not our answer, right? Because remember, we're doing a 1 minus that. So to finish up, we do 1 minus answer, second negative button, and that gets us 0.992. So there's a 99.2% chance that less than 3 fish die. Write that out again. 0.9929. So we're gonna, that rounds up to 993. Next, all the fish live. Okay, these are the same. We just found what if none of the fish dies? That's the same as all the fish living. So we already did that one. That's probability of R equals 16. At least 12 fish live. So this is a probability of R is greater than or equal to 12. Okay. Does that look familiar? Right up here. The only difference is now we're 12 instead of 13. So this is counting 12, 13, 14, 15, 16 options. Right, the probability, adding them together. So we're going to do 1 minus probability of R less than or equal to 11. Okay, these are discrete, not continuous, right? We can't really have 11.5 fish live. So this still covers all of our bases here. So we're doing that one last time here. Finish it up. Okay, go all the way down to, again, to part B, because it is less than or equal to. 16 is our trial, 0.95 is still true. This time we want 11. And just double checking, R is less than or equal to 11. Paste, enter, and we get, again, scientific notation. So we would move this 4, 1, 2, 3, 4, and we're going to do 1 minus that answer. And we'll probably still get a answer very close to 1, so 0.999% chance. Okay. So 0.999. Okay. And that is the end of the lesson. Homework is on Moodle and is also should be on your assignment guide that was handed out. Thank you.